So I welcome you guys to this 3 days class, which is on embedded systems. But basically, we want to learn how to simulate Arduino using Pro Tools simulation software. But I think 3 days ago, I created a poll on the WhatsApp group, and I found out that a lot of persons are not familiar with the fundamentals of electronics, and it will kind of be difficult for us to go forward without you understanding the basics of electronics, because a time comes when you want to be programming your microcontroller, writing code for your Arduino and other development boards. You encounter problems, but now the question arises: can you be able to differentiate the hardware problem from the software problem? That's where the problem comes in. So that's why it's important that you understand and know the fundamentals of electronics before you start writing code or before you start simulating Arduino, because Arduino is actually a development board that is built with a particular microcontroller, which is Atmega 328P. So before we dive into simulating Arduino and installing our Pro Tools, I want us to go through some certain things, some certain basics that we need to know before we go forward. All right. So today we'll be starting with we'll be taking number 1, number 2, number 3, and number 4. Then from tomorrow we can dive into microcontroller and Arduino development board. Hope you guys can hear me.
Yes.
All right. So the number 1 point is we want to get introduced to the basics of electronics design. Number 1 point there. Then after that, we install our CAD simulation software, which in this case is Pro Tools. Then we'll now add the Arduino library inside the Pro Tools. Then we design and also simulate 5-volt power supply using that same using that same simulation software, which is Pro Tools. So now, what we want to do, we want to simulate electronic circuits. But before we go into that, we want to understand what is actually the electronic circuit. Then after that, we are going to be talking about how to start, because a lot of persons have messaged me, called me about, okay, I want to start this, I want to start that, but they don't have a very straight pathway. I know when I started, I had a lot of issues figuring how to start, how to do 1 or 2 things, how to do a lot of things actually. Okay, let me admit. Yeah, I know. Let me admit someone. We can see the screen, right? Can we see the screen now?
I want to say cap.
Sorry about that.
Go ahead. I thought I was seeing your handwriting.
Oh, okay. Can you see the presentation, like what I'm presenting? Can you see what I'm presenting?
I don't think I can only see cap and symbolic. There is cap and symbolic.
Oh, okay. Sorry, let me share the screen. Sorry. I think I have not done that.
Hello?
Yeah, I think I've not done that. Let me share the screen right now.
Hello, sir.
Yeah, can you see?
Hello, sir.
Yeah, I can hear you. I can hear you.
Hello, sir.
I can hear you. I can hear you.
I cannot see the participants. I cannot see.
Yeah, don't worry.
Hello?
Don't worry. Don't worry. We are going to see the screen now.
I say I cannot see the participants.
All right.
Then your cap.
Can you see the?
Okay.
Can you see the screen now? Can you see the screen now?
Yes, the cap is still there. Symbiotic is presenting.
Wow.
He said symbiotic is presenting.
And that's what I'm
there, but in the larger way.
Okay.
Yes, it's okay now. I can see now.
All right.
Yes.
Some other person can talk so that I will know. Can you guys see the presentation?
Yes. Please make it bigger.
No problem. I want to make sure that other persons are following. Can you guys see the screen? Hello?
Please, I can see, but it has gone back to the cap again.
Yeah, I understand. Yeah, I know.
It was clear about 2 minutes ago, but now that's gone. Okay, it's okay.
All right, you can see it now.
Okay, it's all right.
You can see the screen right now, right? Wow.
The cap is
Okay, just give me a second rather. Let me. All right.
no problem.
So, can we see the screen now?
No. See, the participants, the cap, only the cap. Yes. Getting better.
Okay.
Symbiotic is presenting, getting better. It's really the cap I can still see.
Yeah, don't worry. Let me figure what is wrong out.
Symbiotic is presenting. Okay. It's clear now.
All right.
It's clear now, yes.
All right.
Back again.
So, we are going to be taking the first 3 points there. Introduction to the basics of electronics, installation of the Pro Tools CAD software, adding Arduino library to simulate 5-volt power supply. So these are the things that we are going to be doing today. Then tomorrow we can continue. So now, the first thing to do is to understand what we mean by. Please, can we mute our mics, please, because of noise? So the first thing to do is to understand what electronic circuit is all about. Please, can we mute our mics? Solomon Rotimi, please mute your mic. All right. Hope we can see the screen, right? Are you guys with me?
No, your screen is not showing. Stop sharing.
Okay.
Yes, I will see. We can't see the screen.
All right, let me share. Let me do that again. What about now? Can you guys see the screen now? Can we see the screen now?
It's coming up. It's coming up. We're waiting for it to fully come up.
Okay, once it comes up, you can tell me. Just notify me.
Okay.
Okay, you can see it now, right?
Yeah, start sharing.
All right.
It starts radio. And it's
Serious.
okay. You start sharing your screen.
Yeah, I don't know what's wrong with it's automatically stopping this sharing ball.
I can't still see the screen.
There is no this wall, the section of the cap.
So that it is like there's something happening at your end. Anytime you start sharing the screen, it's almost immediately stop sharing. And it says you have left.
Wow.
So,
Okay, the slide is actually important. I would have said, okay, let's start live, but I think it's very, very important that we see the slide. Yeah, can you see the screen now? Can you guys see the screen now? Wow.
Yeah, the screen is sharing now.
All right. You can see the presentation, right?
No? It has stopped sharing. The screen has stopped sharing.
Wow, 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 wow.
Yeah, the screen has stopped sharing again.
I don't actually know what is wrong. I think I don't know, maybe I'll have to send the presentation to the group chat. But I think it's still very important that we please, can we meet our mics, please? Okay, can we see the screen now? Can we see the screen now?
No.
Wow.
The screen is not sharing right now.
Okay.
No.
No, sir. Not sharing yet. That's the screen.
Okay. It's presenting now, but not yet showing the presentation.
Okay.
Yes, you can. It's sharing now. It's okay now.
Okay. You guys can see the presentation, right?
You can see simulate Arduino.
Yeah. All right. So all right. So please, can we mute our mics, please? Can we mute our mic? If you're not talking, please mute your mic to avoid holdbacks. So we are starting with the first one because we've spent a lot of time. So number one thing is for us to understand what electronic circuit is all about. Before we start designing circuit, we're supposed to understand. So because of time, I wanted to ask questions but we've lost a lot of time. So now, once you have a connection, a close connection through which a current can flow, then it's called an electronic circuit. Any closed path through which current can flow, you have your source, you have load, whether you have resistors, capacitors, whatever you have. Please, can we mute our mic, please? Can we mute our mics, please? The noise is too much. All right. So, through which a current can flow, that particular closed path, that particular setup we have is called electronic circuit. Now, a lot of persons want to. I think I will have to. Some persons left their mic. Some persons are talking, so the holdback is too much. All right. So can we still see the screen? There's no way they can respond now. Can we see the screen now? Can we still see the screen, please? You can use the chat section to answer me.
No, you cannot see the screen.
But it's showing now.
No.
Just share the slide to the group chat. Share the slide to the group chat.
All right.
It's like we share to this group, then we can hear the voice from you and follow what you have on our screen.
All right, let me do that right now.
Okay. There you go.
So it's already on the group chat. But please, can we let's do way to mute ourselves because the noise is too much from your end, from you guys' end. All right. So hope you guys can hear me. Hope we all can hear me.
Yes, we can.
All right. Let's move forward. So now, I said initially that electronic circuit is a closed path through which a current can flow. So whether you have microcontroller there, whether you have resistor, whether you have capacitor, whether you have LED, whatever you have, once it's a closed path and current can flow around that closed path, that's basically electronic circuit. So now, if you want to start electronics design, where should I start? That's the number one question you need to ask yourself. What and what have, and which materials should I start with? That's the most important question. Jumping into a particular platform, maybe Arduino, starting with Arduino will not do you any good. So you have to define what you want, then you now know where you can start. So I usually advise people, if you want to start, first of all, understand the fundamentals and the basics of electronics design. Don't just jump into Arduino. Don't just jump into programming 8051 microcontroller. Don't just jump into programming SMT, PIC, ArtMega, and what have you, or maybe Raspberry Pi. First of all, understand the basics of electronics, because let's say you are designing a circuit, or maybe you are working on a water level monitoring system. That's the project you are working on, and maybe your sensor is not getting the water level. Then you should be able to differentiate between, okay, whether is this problem coming from the hardware part, is it coming from the software part. Your ability to differentiate these two phases, these two problems, these two categories is what will allow you to be able to troubleshoot and actually arrive at the particular problem. But if you cannot be able to differentiate these two problems, it will be difficult for you to solve. So electronics is not like pure software development, maybe web development, that if you are having problem, your problem is coming from the code. No, your problem can come from electronics, your problem can come from the software. I've troubleshooted a particular circuit. I lasted for more than 3 days, but the problem is just a capacitor. I was rewriting the code, doing a lot of things, but the problem is just coming from the capacitor. So before you start, make sure that you understand the fundamentals. Know how to use resistors, know how to use capacitor, know where to put diode, know how to use your multimeter to understand and test these components. Okay, I want to admit someone wants to join. Hope you guys can hear me. Hope you all can hear me. Please, if you can hear me, give me feedback so that I will know that you guys are following. Can you all hear me?
Yes, we can hear you. Yes, we can hear you.
All right. So now we've settled the first point and the third point, which is where do I start? Where should I start? If you want to start, you start with the fundamentals of electronics. Practice small electronics project. Build shadow detecting projects, circuits. Play with timers, play with counters, play with operational amplifiers before you graduate to programming microcontrollers and microprocessors and FPGA boards and the rest. So now we've settled the fact that we need to start from the basics. Now, what are the tools that you need for you to start? Basically, you need just your multimeter, breadboard, soldering iron, and your components to be able to start. For you to be able to start, multimeter is very, very important. You cannot design circuit without multimeter. It's not possible at all. Any circuit you want to design, no matter how small the circuit is, don't power your circuit unless you confirm that the circuit is working fine. You cannot design a full project and your controller, everything is on top of the project, and you, without testing your project, you just power on the project. It's not done. You waste a lot of materials. That's actually the difference between pure software and electronics. In electronics, any mistake will cost you money. So if you are not careful, you can burn Arduino board that you got for more than $10. You can damage your GSM module, your GPS module, your MPK sensor, your voltage, your temperature sensor. So before you power your circuit, you need to test and confirm that all the parts are giving what they are supposed to give. If you've worked on inverter, you understand that you will need to be very, very careful with components, else you'll be burning your materials, burning your MOSFET. So it's important that you test before you power on your circuit. So now we have some basic electronic circuit that we have to know about. They are important that we know about them. Without them, it will be very, very difficult for us to move forward. Because in any circuit you have today, you must have capacitor, you must have resistor, you must have these ICs, small ICs inside. So you should be able to understand how to use those ICs, how to use those materials to design a circuit. So we have the basics, some basics components here. We have resistor, we have capacitor, we have diode, we have, this is light dependent resistor. You can use it as a light sensor, or maybe you want to sense darkness, you want to sense shadow, you can use LDR. So we have voltage regulators, we have transformer, we have analog ICs. Most of us, we are familiar with NEE55, like 55 timer. Most of us are familiar with it. So now these are some of the pictures of the components that we are at 3 now. We are in slide 3. So now, having said that, because this class is actually visual, we cannot touch components. So we need to install the Pro Tools simulation software, because this is the software that we are going to be using for this class. So we need to install it, then add Arduino library to the CAD simulation software. And at this point, I think it's important that we try to share the screen. I think it's important we try to share the screen so you guys can follow me. So I will try once more to share the screen and see if it will work this time. So are you guys with me? Can you guys hear me? If you can hear me, please.
Yes,
all right, so I want to try. All right, so I want to try and share the screen again, so that, because I want to install the simulation software. I want to do that while you guys are seeing the whole process.
The screen is not sharing.
Yeah, let me try and do that now. Just give me a second. So can we see the screen now? Can we see the screen now?
Yes.
All right, you can see. All right, you can see the screen, right? All right. So
stopped the screen has stopped sharing.
All right, I'm trying as much as possible to share. I don't know why it's. Okay, you know what will happen? I want to like create another. Let me create another meeting because I don't know what's wrong with this. Let me create another meeting so that. Or can you guys see the screen now? Can we see the screen?
The screen is there. Okay. The screen is
Yeah, the screen is on now.
All right, all right. So first of all, the first thing to do is to open the. This is the folder. This is the software. So you have the software and you have the patch.
again.
The sharing has stopped.
All right, all right, all right. Let me create another meeting. I don't know what's wrong with this particular link. Let me create another meeting. I will drop the link on the group chat right now.
If you have a screen record on your system, like a screen record, if you can do a screen record.
Yeah, I have a screen record. Yeah, I have a screen record, but I want you guys to see it live as I'm doing it. I have a screen record on. So I will try again. I will try again and create another meeting. If it's not working, then I can now screen record and send it to the group chat.